First, we're going to start with drawing the timeline, and we're going to put all the cash flows. And then we're going to find the present value of each cash flow. So we are going to treat each of them as single cash flows and discount them as single cash flows. Remember our present value of single cash flow formula. And then if you add all those present values up, that gives us the value of the bond, right? So here we're not going to use the annuity shortcut to value a coupon bond. We are going to do it the cumbersome way for reasons that I'll be clear in a little bit. And we're going to find the present value of each cash flow first. And when you add them up, that's the value of the bond. So that's step 3, the value, the total value. And now we're going to find the weight of each cash flow, right? How much does each cash flow contribute to the total value of the bond? So we're going to divide the present value of each cash flow by the value of the bond, and that will be each cash flow's weight. Next, we're going to multiply those weights by each cash flow's maturity, right? So how many years from today are they going to be realized in, right? So that's the duration, that's the maturity of each cash flow. We're going to multiply that duration with the weight that we computed above, and then we're going to add them up, and that will give us MacD, the McCalley duration, which is the weighted average of all maturities. Okay, this is much easier to do with practice, doing the work. So make sure you look at the examples and the practice problems in the book. And now I will do a couple examples, new examples that are not in the book. Okay, so let's start with this one. What is the MacD, McCalley duration of a 3-year 4% annual coupon bond with a $1,000 face value and yield to maturity of 5%? Before we even start, remember key bond price properties. 4% coupon rate, 5% yield to maturity. Right away, you should have a very good idea what that implies for the price, right? Coupon rate is less than the required return of investors. So this is not generating enough interest relative to what the investors want. So what is that going to do? It's going to make this less valuable. Price will be less than face value. So this should be a discount bond. When we crunch the numbers, if you don't find this to be a discount bond, we are making a mistake. So we should go back and fix it. All right. So let's do this on paper. So the first step is going to be drawing the timeline. So we have a 3-year 4% annual coupon bond. Zero, 1, 2, and 3. And 4% annual coupon bond with $1,000 face value. Remember, annual coupon amount, capital C, is coupon rate times face value. So that's 40. 4% of 1,000 is 40. This is annual. So each cash flow, each coupon is going to be $40. And then at the end, the last one is going to be the last coupon and face value. And now we have a yield to maturity of 5%. All right, so these are our cash flows. The next step is find the present value of each of these, right? So I'm gonna write present value here, okay? And what's the formula? Present value is future value, FV, divided by 1 plus I raised to n when it's annual, and this is annual, right? Instead of I, we are using yield to maturity. So here, the first one is going to be present value is $40 divided by 1 plus yield to maturity, 0.05, raised to 1. And then the second one is $40 divided by 1 plus 0.05 raised to 2. And then the last one is 1,040 divided by 1 plus 0.05 raised to 3. Okay. So if we write these, if we compute these, the first one is going to be 40 divided by 1.05. And I'm going to store this STO1. I don't want to make a rounding error, but here I'm going to write it to 3 decimal places. 0.95. That's the present value of the first coupon. The second one is 40 divided by 1.05 squared. That's 36.281. Not surprisingly, it's a little less. $40 in 2 years, worth less today than $40 in 1 year. So let me store this, STO2. Okay, and then the last one is 1040 divided by open 1.05 raised to 3 close equal 898.391. Okay, so these are the present values, and let me store this STO3. All right, so now if I add these up, which is the next step, the sum is going to be the value of the bond, right? So let's compute these. The third one plus recall 2 plus recall 1, and then let me store this. I'm going to need this, so I'm going to do STO4. The value of this bond is 972.768. All right, so that's P bond. All right, and just to confirm, if you want, pause the video here and compute the value of this bond using the annuity shortcut formula, and you should get exactly the same number, right? The next step now is to compute the weights. So how much does each cash flow contribute to the total value of the bond? So what we're going to do is we're going to divide these one by one by the total value, right? So 38.095 divided by 972.7868 is the weight of the first one. So recall 1 divided by recall 4 is the weight of the first coupon payment in the total value of the bond, 0.039162. Okay, let me go 6 decimal places, even though I'm keeping everything in the calculator. And now I don't need this present value anymore, so I can replace, in the memory of the calculator, I can replace the present value for that first coupon with the weight of the first coupon. So I'm going to do store 1. So this is my new stored number. Okay, and then I go recall 2, 36.281, divide by recall 4, the total value equals, that's the weight of the second one, 0.037297. So the second one is contributing this much to the total value. Store 2 and recall 3, present value of the face value, divided by recall 4, that's the weight of the last one, and that's the big one for this bond, right? 0.923541. So these are the weights. Now, here's a sanity check you should do. If you add these, you don't really need to do this to compute MacD, but as a sanity check, if you add these up, what should the weights add up to? So think about that, right? So these are each present value divided by the total, right? And we divide them, and if we add them up, so these are how much each cash flow contributes to the total value. So these have to add up to 1. Okay, if they don't, you made a mistake. All right, so altogether they account for the total value of the bond. So now the last step is multiplying these. Oh, by the way, I should store 3, the weight. Okay, so I have my weight stored, recall 1, recall 2, recall 3. All right. And now let me multiply present value times weight. Right, so now we are taking the weighted average by multiplying these and then adding them up. So the first one, I'm sorry, not present value times weight. It's duration times weight. So we're going to do the weight of each one multiply by the duration of each cash flow, right? So the first cash flow has a duration of time to maturity of 1, the second one 2, the third one 3. So we want to weight these by these weights that we computed. So 1 times 0.039162 is 0.039162. So we don't need to do anything. Plus, now we got to multiply the second weight with the time to maturity of that cash flow, which is 2. So we do recall 2 times 2. 0.074594, and now I do store STO2. That's the new number I need in my calculator. And then the last one is recall 3, that was the weight, times this cash flow is in 3 years, it's coming from here, all right, times 3, 2.770624, and let me store that STO3. Okay, so I have these 3 numbers stored. Now if I add these up, this plus recall 2 plus recall 1 equals 2.884. Usually I will round these duration measures to 3 decimal places, and this is in years. Okay, because remember, this is duration, this is a duration measure, and with these numbers, if the unit is years, so the average duration of the cash flows, weighted average duration of these cash flows is 2.884. That's the MacD, Macquarie duration of this coupon bond. And the higher this number, the more sensitive the bond is to interest rate changes.